Hello guys, welcome back to a new video. Today we will be discussing about the degradation of purine nucleotides. So here the degradation of AMP and GMP will be discussed. So first of all we will be looking into the degradation of AMP or adenosine monophosphate. So this is the structure of AMP. This AMP can undergo two reactions, either one of the two reaction sequences which is shown here, and form inosine. Then this inosine is further degraded to the final product. So first of all we will be looking into this reaction sequence, first reaction sequence. So here AMP or adenosine monophosphate in presence of AMP deaminase forms IMP or inosine monophosphate. So in this step a water molecule comes and one of its hydrogen joins with this NH2 and leaves as NH3. Then the second hydrogen of this water molecule joins with this nitrogen and forms NH group. Then this remaining oxygen attaches with this carbon and forms a double bond over there. So this is the formation of IMP. Next, this IMP in presence of nucleotidase enzyme forms inosine. So here a water molecule comes and cleaves this phosphate group of ribose 5-phosphate and form inosine. So here the OH group of one of the hydrogen of this water molecule leaves with this 5-phosphate group, and the remaining OH group of this water attaches with the remaining CH2 group of this ribose and forms CH2OH. Thus, this inosine is formed. So, in the second reaction sequence, that is either one of this pathway can happen. So, in the second reaction sequence, this AMP may in presence of nucleotides enzyme form adenosine. So, here water molecule comes and cleaves this phosphate group from here, from this ribose 5-phosphate and forms adenosine. So here the hydrogen, one of the hydrogen of this water molecule leaves with this much group of phosphate group, and the remaining OH of this water molecule attaches with this CH2 and forms CH2OH. That is this formation of adenosine. Next, this adenosine in presence of adenosine deaminase forms inosine. So here water molecule comes and one of the hydrogen of this water molecule attaches with this NH2 group and leaves as NH3. Then the remaining hydrogen of this water molecule attaches with this nitrogen and forms NH group there. Then the last oxygen which is present here joins with this carbon and forms a double bond. This inosine is formed from adenosine. Then this adenosine may also undergo another phase, that is it can be degraded to adenine, that is in presence of purine nucleoside phosphorylase enzyme. So what happens here is a phosphoric acid group comes and cleaves this group, that is this ribose, by attaching itself to this ribose as 1-phosphate. So this phosphoric acid attaches to this ribose first carbon and leaves as ribose 1-phosphate. Thus, this much group is left, that is the adenine. So this is the, first of all, this AMP is degraded to inosine. Now, we will be moving on to the further degradation of this AMP. Inosine thus formed, then in presence of purine nucleoside phosphorylase forms hypoxanthine. So here, a phosphoric acid comes and attaches with this ribose and cleaves this much group as ribose 1-phosphate. Thus, this hypoxanthine is formed. Then, this hypoxanthine in presence of xanthine oxidase forms xanthine. So here, water molecule comes and the oxygen of this water molecule attaches with this carbon, and the already present hydrogen here, that is the hydrogen which is already present here, that is in this carbon, will rearrange itself to this nitrogen and forms NH group, and there is a rearrangement of electrons and forms a double bond O here. Thus xanthine is formed, and the remaining H2 and another molecule of oxygen joins together and leaves as H2O2. Next, this xanthine thus formed, then again in presence of xanthine oxidase forms uric acid, which is the final product of the degradation of AMP. So here also a water molecule comes and this oxygen of this water molecule attaches with this carbon, and the hydrogen which is already present here rearranges itself to this nitrogen and forms an NH group there, and this oxygen will be forming a double bond with this carbon in order to maintain the valency. Thus uric acid is formed. So this is the degradation of AMP to uric acid. Now let us move on to the degradation of GMP or guanosine monophosphate. So this is the structure of GMP. This GMP at first in presence of nucleotidase enzyme form guanosine. So here water molecule comes and cleaves this much phosphate group from this ribose 5-phosphate and forms this guanosine. So here the hydrogen, one of the hydrogen of this water molecule joins with this phosphate group and leaves. Then the remaining OH group attaches with this CH2 and forms this ribose here. This guanosine is formed. Then this guanosine in presence of purine nucleoside phosphorylase enzyme forms guanine. So here a phosphoric acid comes and attaches to this ribose here at first carbon and forms ribose 1-phosphate and leaves as this much group. So this ribose 1-phosphate after formation leaves from this guanosine, and thus guanine is formed. Then this guanine will in presence of guanase enzyme forms xanthine. So here water comes, there is addition of water molecule, and here one of the hydrogen from this water attaches with this NH2 group and leaves as NH3. Then the oxygen of this water molecule attaches with this carbon and forms a carbon-oxygen bond there. Then the remaining hydrogen of this water molecule attaches with this nitrogen and forms NH group. Thus there is rearrangement of electrons, and this double bond is moved to this carbon double bond O. Thus xanthine is formed. This xanthine then in presence of xanthine oxidase forms the uric acid, as we have seen in the last step of AMP degradation. So this is the degradation of GMP. This is all about the degradation of AMP and GMP.